Kevin Smet is going to show us how to get better surface seams with implied curvature.
So what I'm going to do is I'm going to make a square, and I'm assuming that your surface was a square judging by the name, and that you created it just like this, which is the default configuration. And if I put on the shader, it's not that evident that there's a seam there, but if I go to double horizon, it's pretty clear that there is a seam right in the middle. That's going to be larger than our tolerance. And that is confirmed if I toggle the model on again and ask for just tangency. That's good enough right now. And you can see that, yes, there is a tangency break, and it's a little over half a degree, so that's actually quite a lot. So the reason for this is in the CVs. So if I turn on the CV hull of the surface, you can see that the CVs are very straight and neat, but that doesn't mean that it's good. So I'm just going to turn on Explicit Control 5x5 because the curves were 5x5, but I mean, I didn't have to do this, but I just like it explicitly on. So if by boundary 1 I go for implied tangent, you can see the CVs change, and implied curvature, you see the CVs change as well. So this tells me that there is a difference between just regular free and implied curvature and tangent. But it's true that the two curves that you're generating from are curvature, but square interpolates the four boundaries. So it doesn't necessarily mean it's going to be smooth. So if you see the CV there on that curve that it has to follow up to that boundary, those two CVs need to join up. You can see when I go for implied curvature that the two CVs near the center actually need to be quite a bit higher. So the CV on the other boundary is driving the bad surface set. Now you can see with everything free, it's a very neat surface, but it's too low, and it's forcing that seam down the middle. So I do want to put it on implied curvature because it's pretty neat that way. So if I toggle the model off and I have a quick look, it looks very, very good, very smooth. Let's put it on double horizon, and you can see that there's no seam. So we're well within our tolerance. And if I put a quick locator on there, ask for tangency first, you can see we're tangent, and if I go into the information window and ask for curvature, then it's curvature as well. So we've got a nice transition. But now our CVs are looking a little weird. So we can just slide the CV, you know, that curve CV. And, you know, we can do this with the new hotspot editor. It's pretty cool. So we can choose slide, and sliding the CV won't really change the shape of the curve very much. So you don't have to worry about that. You'll still hit your mesh. But you can see that the CV distribution is now very neat and with implied curvature. So it's also smooth at y equals 0. So if I delete the surfaces, I do have some other options. For example, a rail. So if I go for a 2x2 rail and pick the horizontal curves as my gens and the vertical ones as the rail curves, you get a similar CV setup. And if I now manipulate rail 1 with the same options there, you can see that the CVs move just as much. It's the same thing. So a rail does not change it at all. It's still an interpolation. We can use a 1-1. So if we pick just the top curve as the gen curve and the y equals 0 as the rail, with sweep mode set to parallel, that's pretty important. We get a nice even CV distribution. And look at the funny thing. If we do rail 1, nothing changes with implied tangency, implied curvature. It just doesn't change, you know, because now it's being explicitly driven by a single rail. However, notice we're not hitting our geometry anymore. So, you know, we've got a huge deviation in the bottom right, so we don't want that. So just going for a regular square with that 1 CV slid is the solution that I would do here. And you can leave implied curvature on. It's really quite okay. Notice, though, if I go back to free, the CVs move a lot less because they don't get kinked as much because of that one CV on boundary 3 that was driving it. Now, I'd still put it on implied curvature just to be safe. It really is the right solution here. I would suggest overbuilding instead of building half and using layer symmetry, but it's really all up to you. You can see the result is actually very neat. We have curvature continuity here, and there's not much to blame here. So I hope that I was able to help you a little bit. I sure had fun analyzing this.
I'm Graham Bullock, and all that remains for me to do is to thank Kevin De Smet for that great presentation, and thanks for taking the time to watch his video.